Homework 9 is due tonight. I need to finish or continue grading exam 2. So we're going to skip a quiz for now. No quiz this week, maybe next week, but next week is Thanksgiving, so we'll see. Okay, and we are doing notes for homework 10, which is due on the 23rd. Notes for the homework. So this homework assignment is about radicals, and we're going to start off. I think we want to start with this property. It's called the rational exponent property. Like rationals are fractions. So if you have an exponent, that's a fraction. If x is a real number, and n is a positive integer greater than 1. N is an integer, and it's such that n is greater than 1. The nth root. So this is your root. It's got a little hook here, and the root, or I guess that's the radical sign, and the root goes right here in this little corner to represent any root that's greater than 1. You can write it as x with the power of 1 over n. We need a special note that x needs to be greater than or equal to 0 for certain values of n. We'll get more into that soon. So if you have an even root, this needs to be a number greater than or equal to 0. We'll write it down. Also, like you could think of it as if you have, or you cannot take an even root of a negative number. Let's practice. Square root of x is x with a power of 1/2. Cubed root of x would be x to the 3rd. I'm going to do now is, let's do a 4th root of x to the 8th. So take what's under the root, the x to the 8th, and keep it in parentheses. And this is a power of 1/4. Now with the exponent rules, a power to a power, you multiply those numbers together. So 8, I can put over 1 if it helps. Read 8/4, which would reduce to 2. We're going to do cubed root of x. Let's do a to the 12th. So your cubed root will become a 1/3 power on a to the 12th. So it's a to a power of 12 times 1/3, or a to a power of 12 over 3. So I've got a to the 4th. I don't know if you can see that down here. So my suggestion is to try to use exponent rules. And my goal usually is to have a way to make the root match the exponent, and then they can kind of undo each other. So we'll write it, and then we'll put it up mathematically. So try to get the root and exponent to match. Now I'm thinking we should put up the labels for everything. So if you have an nth root of a to the x, n is called the root. This whole value, everything under the root, is called the radicand. And on that value, there's this exponent. And then this symbol here, this is called a radical sign. And then I don't think it will come up really on your homework, or it's not. Let's see, how can I? It's this whole part here, all of this stuff is called the radicand, the stuff underneath the root. radicand. All I really was wanting to talk about is getting this part to match that part, and I'll show you why you want to do that. So let's say that you can work out the problem so that your root is, n, and you've gotten whatever's underneath the root, the radicand, to have a power of n. So let's say your base is x and it has power n. So I can try to find a way to get the root and the exponent to match. Then this part, the radicand, x to the n, has a power of 1 over n. So you take your x, the power is n times 1 over n, or n over n, which is 1, which we know from before is x. So let's say you've got a cubed root of 27. And let's introduce this. We're going to simplify the cubed root of 27. So we'll take this problem and just do a factor tree on that number, 27. 27 factors into 3 times 9. 9 factors into 3 times 3. And the factors of 27 are at the end of the branches. So we're going to write 27 as 3 times 3 times 3. 3 cubed. Okay, so I've got the root 3 matching that exponent 3. So this 3, just like this x right here, comes out from under the root. There was that nth root of x to the n, and it resulted in being just x. So if I have a cubed root of 3 cubed, the result is 3. Okay, so we want to simplify the root of 25. And it's just, what's it called? Known or, how do you say? Assumed that the root is 2 if there's no root written right there. So if there's just an empty spot, the root of 25, you just need to know that it's a square root. It's just 2 as your root, and then under there is 25, which we're going to factor. 25 is 5 times 5. So we're continuing on with the square root of 5 squared. Once I've got that root and exponent matching, I can bring the 5 out from underneath the radical sign. Let's do one more. Simplify. This one's going to have the cubed root of x. I'm going to go with 30, power 30. Okay. So I want to use exponent rules. With the cubed root of x to the 30th, I want a power of 3 to match that root 3. So I have a cubed root, and x can be written as a power of 10, and that raised to a power of 3. Because that would, like going backwards, you'd go 10 times 3 to get that power 30. Cubed root of 10 of x to the 10th to the 3rd. So the power and the root match, and what comes out from under there is x to the 10th. And again, this is just one way to work through the problem. If you have another way and you follow the correct rules, the exponent rules and everything, you get the same answer. Okay. I've got more examples. So we're going to work with problems that look like this. We still want to simplify. Sorry. We're looking at something like 36 with the 1/2 power. So we're just going to work it out over here and I would start by rewriting the 1/2 power. It's root 2. What's in the denominator is your root. And technically what's in the numerator is going to be an exponent on what's here. We'll actually probably get to that on Thursday. But it's a square root of 36. And you'd want to factor 36. You could go all the way down to prime factors, but if I just do 6 times 6 is 36, and I can have a power that matches the root. Square root of 6 squared. So that power and that root will undo each other and leave 6. Let's do, it's 64 with the power of 1/3. Okay, so this is how I would do the problem. I would usually want to change that fraction that's in my that's my power, into a root. So I want a cubed root of 64. Again, it's whatever value's in the denominator that ends up as your root. Okay, and then you can factor 64. And as I said before, you could fully factor this number, or you can factor it in a way that has a exponent that matches the root. So it turns out 64 is 4 times 16. 16 is 4 times 4. So I could write this as a cubed root of 4 cubed. So when you have that exponent matching the root, you can bring that number 4 out from under the radical sign. Okay, let's move on. We might come back to more examples later, but I want to talk about, it's called this, let me see. I don't know if it has a special name, but just when you take the square root of a number, the result needs to be positive. You have positive answers for square roots. Or I guess let me get on the board. Non-negative numbers are going to be your square roots. So really the whole point here is that when you have a square root, the result is non-negative. It's a non-negative number. Such that the square root of x squared would be x. So to start to drill this idea in, we're going to get the square root of 4 would be a square root of 2 squared. And you have positive 2 as your answer. So root 4 is positive 2. Take the root of 9. So you have a square root of 3 squared. Positive 3. Again, root 9 is positive 3. There's only one answer to this, and it's the positive number. Let's do root of 36 would be a square root of 6 squared. And you get positive 6. The root of 36 is positive 6. Let's do one more. Root of 49 needs to be positive 7. Only one answer is the positive one. Okay, but it could get a little tricky after that. If you have a negative sign outside of the root, then you're taking a negative of that root. So looking at something like this, negative root 49. If it were me, I would think of it like you have this negative, and let's write the problem. 49 is a negative of whatever the root of 49 is. So negative of positive 7. So you will get negative 7. That is from the negative sign sitting out front. It has nothing to do with the actual root part. The root is a positive number, and then apply that negative symbol that was given to you. Okay, and it gets even trickier if you have a negative under the root. So this is where we have to start talking about even roots and odd roots. Root of negative 49 is not a real number. It is a complex number, but we're not using those numbers this semester. So we're not going to have an answer for this in our class. But it does have a value, an imaginary value. Okay, first of all, it's not a real number. Okay, these are called complex numbers. We're not even going to get too into it. That's not the focus of this class, but it could come up in another class where you can like work with this value further, but right now we're stuck at not having a real number solution to something like this. Same for any even root of a negative number. An even root. Is not a real number. We're not even going to go too far into complex numbers. We're just going to say if it's able to be simplified, we simplify it. If not, then we'll say, like if it's not a real number, we'll just write down not real. Okay. Something really straightforward would be the square root of -1. Okay. This is not a real number. So just as a side note, this is defined to be I, which is an imaginary value. The imaginary number I is the square root of -1. But we're not using imaginary numbers, we're only sticking with real numbers, and this one is not real. We had a fourth root of -25. It's not a real number. The root is even and the value underneath the root is negative. So it can't be simplified in the real numbers. Let's do one more just to be clear. Let's put a bunch of negative signs. Let's take a negative root of -9. The problem is this part, the even root of 2 and the negative number underneath. So this is not a real number. So if it's negative, it's still not real. We can work with even roots, odd roots of negative numbers. We'll do it once, like what the process is, but in general, we just bring the negative out from under the radical sign. Okay. Before we do that though, I want to introduce two rules. It will help explain why we can do this trick. Let A and B be non-negative numbers. And the root n is a whole number. With n greater than 1. Looking at this, I could have said integer again, but basically something you can count on your fingers starting at 2 and past. So 2, 3, 4, 5, 6, 7, 8, things like that. Okay, then the first result. The nth root of a times b is the nth root of a times the nth root of b. Nth root of ab is nth root of a, nth root of b. Make sure you copy down a matching root. So if you have a cubed root here, there needs to be a cubed root of a there and a cubed root of b multiplied with it. So it's this times this. I don't know if that helps. I don't think so. Okay. That's one of them. The other one. Is to have an nth root of a divided by b. You can break it up into the nth root of a divided by the nth root of b. And again, make sure you keep this root in that little corner for both parts. So nth root a over nth root b. Let's do this problem really fast. We're gonna have a cubed root of let's do x cubed times c. Like so, or let's do a cubed times b. Okay. Here's a cubed root of a cubed b, which I can break apart as a cubed root of a cubed multiplied with the cubed root of b. The first part, the exponent and root match. So what's left over here is a. But here, since the exponent is less than the root, this is as simplified as it can get. So just copy down this cube root of b. And that's as good as it gets. Okay. Do more practice problems soon, but I just want to write down that if you take an odd root of a negative number, we can bring the negative out from under the radical. And then we'll do examples to show you why. We're going to do it example like this. Yeah. We'll do a negative x cubed. How about x to the 6th? And then we'll do a cubed root of that. Okay, so this time, well, in the future, I would just bring this out and have a negative cubed root x to the 6th, but this time we're going to work through all of the little parts. First part is I would write this negative as -1. And then I would use the rule. I have a cubed root of -1 multiplied with the cubed root of x to the 6th. So first, working with -1, I can rewrite -1 with any odd power, and it's still -1. So I'm going to pick a power of 3, so that way the root and power will match. So I can write this as a cubed root of -1 cubed because -1 cubed is -1. And I want this 3 here to match with that 3 right there. Okay. For the other part, I also want the power and root to match. So I can write x to the 6 as x squared and then cubed. So that root and power will undo each other and leave x squared. And with the cubed root of -1 cubed, what's left is -1. So negative x squared. So we can do a trick like this with any odd power for that -1. We can bring it to the same odd power up front. So this time we're just going to jump right to it. We want to simplify the cubed root of -125. Since it's an odd root, I can bring the negative out from under the root. It happens in the same process that we did in this problem. So this negative will end up out front, and you'll have a cubed root of 125 to find. I would factor this 125. Let's see. 25. Just 5 times. So this is a negative cubed root of 5 cubed. So when that root and power match, what's left is 5. And don't forget your negative sign out front. -5. I feel like we're gonna do, let's do something like a root of negative. Let's put a to the 10th. So just rewrite the problem. Since there's an odd root, I can bring the negative out front, out from under the root. Okay, and then I'm going to break this up into pieces. I'm going to have a -5th root of a to the 10th multiplied with the 5th root of b to the 25th. This is just how I feel comfortable solving the problem. If you want to do it in a different way, that's fine, as long as you follow all of the correct rules for exponents. So again, don't forget your minus sign. It's a negative of 5th root. And for a to the 10th, I would write it as a squared into the 5th. And then a 5th root of b with the power 5 and then a power 5. Negative a squared times b to the 5th. Which I'm kind of remembering there's sort of a shortcut here. You can, or if your root can divide into the exponent, then it will simplify into that. I guess I'll just point it out. I'm having a hard time just explaining it, but like if you take this 10 and divide by that 5, you'll get the a squared. If you take your 25, divide by that 5, you'll get this power 5 here. So try to maybe see if you can divide these powers by the root evenly, and that's a way to simplify. Okay, but let's just keep practicing simplifying these things. Okay, we have we take the root of 200. First, I would start factoring this. So 200 is 2 times 100. And I can write 100 as a number squared. So we're going to just move here to the root of 2 times 100 being root 2 times root of 100. Then let's have 100 written as 10 squared. And this is a square root. So there's an unwritten root 2 and a power 2. So what's left right here is 10. And you can't simplify this part. So it's root 2 times 10. It's often written with that number value first. So you would put your answer down usually as 10 root 2. It's the easiest way to read it. just to mention, like, I'm gonna make up this next problem, but I've sort of shown this to, let's say, a calc class, and it tricked probably most of the class. So watch out for something like this. If you have a root of, let's go with x squared plus y to the 4th minus z to the 8th. And it says simplify. So the rules earlier for the radicals was when you are multiplying radicals or dividing radicals. There aren't any rules for adding and subtracting under the radical. So this does not simplify into x plus y squared minus z to the 4th. It doesn't simplify at all. It's fully simplified already. But we'll just put this as simplified. Or it can't be simplified further. Let's look at one that we can do. Let's do the root of, let's do x to the 2nd times y to the 4th. And you know what? We'll divide by z to the 8th. This one we can work with. We have multiplication and division, which we have rules for. Okay, so let's just copy down the problem. And I'm going to just start, well, first of all, just check that there aren't any ways to simplify this expression that's under the radical sign. There's only one value of each variable, so we don't have to like move anything around or use exponent rules. What I would do next is break this up into the root of the numerator, x squared y to the 4th, divided by the root of z to the 8th. Then I'm going to just go ahead and keep this kind of together. So what we're going to do is underneath this root in the numerator is have x squared and y squared squared. And then a square root of z with the power of 4 and then raised to the power of 2. So that power right there matches the root of 2. And I mean, this step from here to here does come from the rule where it's like the root of this times this is the root of this times the root of that. But just to save some writing, we've got a square root. And on x, there's a power of 2. So what we have here is just x. And then for that square root and for y squared, there's this matching power of 2 out here. So we can take this part y squared out. And then with the z down in the denominator, there's a root 2 and a power 2, which leaves the z to the fourth. Then again, I'll try to talk through this kind of shortcut. I remember learning it from my teacher, but I'm having a hard time like writing down how you do it. But looking at the problem, there's a square root. You take your power 2, divide by 2, and it leaves your power 1. And this power 4, divide by 2, gives you that power 2. And this power 8, divide by 2, gives you that power 4. So that's something that you kind of start to notice. If your root can divide into the power, it'll just simplify like that. Okay. Okay, we're going to simplify a root of 7 over 16a to the 6th. Start with the problem. Then I would use that rule to have the root of 7 over the root of 16a to the 6th. Okay, so 7 is fully factored, and you can't simplify the root of 7 any further. So this numerator is going to stay like that. For 16, we can factor that part as 4 times 4. And I want an exponent that matches my root of 2. So I'm going to stay here with 16 as 4 squared. So the root of 7 is as simplified as it can get. This root, square root of 4 squared times a to the 6th. I could do that part where I get the matching exponent so that the exponent and root are going to undo each other. But I'm going to also but instead I'm going to try to use that shortcut I was trying to explain. So this root 7 stays. You've got 4 with the power of 2 divided by 2. So 4 to the power 1. A has a power of 6 divided by 2. So A has a power of 3. Okay. We're getting closer to the end of class, and I'm trying to just do good examples for you for helping you with your homework. Let's do this one. It's a cubed root of a negative number. It's negative. Let's just go with a to this. No. Okay, it's negative 27, a to the 6th, b to the 9th. We've kind of practiced factoring 27 a few times, but that's okay. We can keep doing it. So 27 is 3 times 9. 9 is 3 times 3. Okay, just copy down the problem. With an odd root, you can take the negative out from under the root. And actually, instead of putting this 27, we're going to replace it with its factored form of 3 cubed. And I mean, we could do all the work like I was doing before, and it's in my notes to do the exponent rules to get a power that matches the root. But I want to try to talk through using the trick. So you've got the negative sign. And for 3, we want to take that power, divide by the root. So it's 3 with the power of 3 over 3, 3 to the first. A, we'll take the power and divide by the root. So A has a power of 6 over 3, which is a squared. And with B, we'll take the power 9, divide by the root of 3, and get B cubed. Okay, we should probably call it good right there. So I've got more examples and a few more results to talk about, but then you should be able to complete all of your homework problems. So we'll meet on Thursday to finish up notes for homework number 10. Awesome. Stay if you have questions though.